I mean, do you any doubt at any specific point? So you can ask.
Sir, I have doubt when to write.
Sorry,
When
your
there
voice.
is,
Yeah, yeah, good.
sir, when there is, let me open. Sir, I can share a screen.
No, you. I don't think you are able to share this. Then okay, so just tell me your problem in. You're talking about in. Okay, let me go on the portal itself. Okay. Meanwhile, everyone have gone through the lectures video of. I mean, sorry, not lecture. Solve with the PDF slides of week 11. We had already uploaded on the portal.
So today is the Solvita session. This is the Solvita session, right, sir?
No, basically we plan to. I mean, what's my plan? I will take the doubts from week 11 and 12. Okay. Basically,
Oh,
because we have already released the solve with the PDF. Okay, and I think we had sent an announcement. I mean, you can go through that. If you are doubt in that PDF, then you can ask at the related to that.
okay, sir.
Fine. Okay, so meanwhile, what I will do, I will take some one or two questions from week 11, because in the last session, I think I have discussed questions related to each topic, right? Then after that, I will take the questions from week 12 solve with us PDF, right? Will that be fine? Then we will be able to cover the questions related to all the content of week 12. Will that be all right for everyone?
Yes, sir.
Okay. Yes, yes. What's your doubt in this question number third?
Sir, why we take mod x bar minus 4 greater than c? Why not only mod x bar?
Why did you take? Okay. Can you tell me what we are okay? What we are taking in case of single test? How will you decide your test?
Sir, based on the alternative hypothesis, if it is greater than c, then we take x is greater than c.
I mean, x bar is greater than some critical value,
Constant
right?
c.
Okay.
Yes, sir.
Okay. And okay, if there is two tail test, that means what?
There will be two sides.
Single has
One is
raised.
greater than and one is
Yeah.
less.
Yes. Okay. So basically, in case of the two tail test, we are checking the thing is that we are going to check how much far is your sample mean from your population mean. Okay, what's the absolute difference between these two? Whether x bar is greater than some mu plus c, or x bar is less than some mu minus c. Okay, so that I mean, in that way we are deciding our test in case of two tail test. Okay, so in
Sir,
single
can
case,
can we can we write x is greater than c or x is less than c, not including mu?
okay, okay, so you are okay. You mean okay? Can you try x bar? So you are simply saying x bar should be greater than c, or x bar should be less than minus
Less.
c, right?
Yes, sir.
Okay. Okay, just can you try? I mean, did you try it first of all?
No, sir, I didn't try.
Okay. Just try on first, and then we can discuss. Okay. Basically, the key thing, what I'm trying to say, we are going to see how much far is my x bar. I mean, whether I'm trying to say whether x bar is greater than some mu plus c, or x bar is less than some mu minus c. Okay. If it's one still, I will simply say x bar is greater than c, right? Because we are talking about something like that. Let me go there. Basically, in one tail test, right? Okay, let me draw it. Okay. In one tail test, what we are seeing, we are basically observing something like that. This is Z alpha and this should be greater than, right? Then I will reject, correct?
Yes, sir.
And this is your mu. I mean, G equal to 0, correct? But in
Yes, sir.
two tail test, we are interested in both sides, right? Okay. So, okay, just try this one. If you are saying this is a good idea, I mean, then you have to see x bar less than minus c, not only c. Okay. because if one side is C, then it should be minus C. If you are talking about modulus of x bar, okay.
Sir, it will affect answer or it is the wrong method?
No, I don't know. I need to check actually. Okay. But
Okay, sir.
as far I know, so we are checking the defining the test like this. I mean, we are interested in whether my x bar is greater than some mu. See, it's a simple intuition, right? Whether x bar is greater than mu plus c or x bar is less than some mu minus c, right? Okay.
Sir, but I don't understand why we include mu. If we don't include it, will affect question or not?
That's why I'm saying just try first and then we can discuss. Are you getting my point, Arbab, right?
Yes, sir.
Yeah,
Okay, sir. I will try. Then I will ask.
see, basically, okay. Let me tell you one more thing. If you're saying x bar is greater than c and x bar is less than minus c, okay, I will give you some hint. Okay. So what? How will you decide your test? I mean, see, at the end you will get your alpha will be what? Probability of you will be doing probability of x bar is greater than c given h naught plus probability that x bar is less than minus c given h naught, or
Yes, sir.
simply probability that modulus of x bar is greater than c given h
See.
naught, right?
Yes,
You
sir.
are saying like this. I mean,
Yes, sir. Yes, sir.
this is your point, right? Now just do what I'm trying to say. Just put the just convert this in standard normal variate and then see whether you are getting the answer as same or not. Are you
Okay,
getting
sir.
my idea? Okay. So
Yes, sir.
thing
Yes,
is
sir.
same. At the initially what we are doing, modulus of x bar minus mu greater than c, right? This is something we had decided our test, right?
Yes, sir.
Now you as per your idea, why we can't do like this, okay? Okay, just do it
Yes, sir.
like this, okay? Or else what you can just do and let me know what the answer you got, okay? Or else you can tag to me on discourse. I will tell you on that part, okay? I will also check. I will solve it in this manner and will cross verify whether we are going to get the same thing or not. Okay. Just
Okay, sir.
only key thing you have to observe. You have to convert this and g. So it will be c minus mu divided by sigma. I mean sigma by root n. Okay, something like that. Okay,
Okay, sir.
got it? Yeah, yeah,
Yes, sir. Thank you.
yeah. Okay, fine. So any one of you doubt, any doubt related to week 11 concepts, or we can move to the week 12. Or else, what we can do, we can discuss the questions from the slides of, I mean, solve with the slides of week 12. In that slides, more or less, we will cover the all the questions related to all the topics of week 12. Which should, what should we prefer?
Sir, can we go to solve with us for week 11?
Do you any doubt in that PDF?
Yes, sir. Two questions I have a doubt.
Okay. Tell me in which question you doubt.
Sir, first, the third one?
Third one, 2B or question
No,
number
sir,
3?
question 3.
Okay. What is your doubt?
Sir, I am not able to understand the language of the question itself.
Okay.
Means I am not able to mathematically translate it.
Okay. Did you have you seen the solution?
Yes, sir, but it is kind of very technical to me. So if
Mm-hmm.
you could explain it.
Okay. Sure. Okay. So question says a commonly prescribed drug for relieving nervous tension is believed to be only 40% effective. That means this is your success probability, right?
Yes, sir.
I mean success probability says defective is 40%, right? Now to determine if a new drug is superior in providing relief, okay. Suppose okay, how will you decide whether it's a superior or not?
It is more than 40%.
Okay, basically, I'm saying I'm interested to check whether it's superior, right? So H naught, it will be P equal to zero point 0.4. This is something we have given, right? For superior, I will check as my alternative will be P should be greater than 0.4, right?
Yes, sir.
Now, what question is, suppose the 100 people who are suffering with the nervous tensions are chosen at random. Okay, how many samples they have taken? They have
100.
taken 100, right? Correct.
Yes, sir.
Now, if more than 50 of them are found to be relieved, we reject the null hypothesis and new drug will be considered superior to superior to the one currently in use. Basically, they have taken sample of 100 people, right? Now you will be interested, you have to check about this 100 people, okay? Okay, how will you decide our test? We are simply deciding T is greater than some C for this, correct? I will reject H naught if my T is greater than T is nothing but you can define as how many peoples are in going to be relieved in this 100 samples. Are you getting? Yes or no?
Yes, sir.
Okay, so here C is given to us already. Means if there is more than C more than 50, I will reject H naught. Then we have to just proceed. Yeah, this is something we have given, right? So basically, each xi is you can define whether it's relieving or not for that person. Okay, for either people. Okay, then
Okay, sir.
T will be summation of each xi, and we know sum of NIID Bernoulli is nothing but binomial, right?
Yes, sir.
Got it?
Yes, sir. Thank
Then
you.
we have to just proceed. What is the type 1 error? And type 1 error is probability of rejecting H naught. When you will reject, T is greater than 50. Given that H naught is what? P is equal to 0.4. We have to just put the value, we will get the answer. Right?
Yes, sir.
Yeah.
Thank you, sir.
In any other question?
No, sir.
Sir, I have one doubt.
Mhm. Yeah, go ahead.
Yeah, sir, I have one question. So, I was looking into the solve with that questions, right? That tutorial 1 and tutorial 2 in week 11. Okay. See,
Okay.
one doubt that I faced, right? Wherever that beta is coming, which is the power, right?
Yes, 1 minus beta.
Yeah. So that's where I'm getting confused. Where in some places we do, 1 minus beta, because if the power is given as say 0.5, but then when we equate it, we are taking it as 0.95, something like that. I don't remember the exact question number.
So can you check? Okay, let me tell you basically what is this alpha and beta. Basically, alpha is nothing but alpha represents it's called the probability of type 1 error. Okay,
Correct,
what is
yeah.
probability of type 1 error? It is probability of rejecting H naught when H naught is true.
True.
Okay,
Yeah.
and beta is nothing but it's called probability of type 2 error. Okay,
Yeah.
and what is this type 2 error? Probability of
Of
accepting the H naught when H1
H
is
is true.
okay. Now you can relate these things in something real scenario. Suppose there is a manufacturer of owner of a manufacturing company. Okay,
Okay.
something medicine bottle or anything, any product is is there. Okay,
Okay.
so how will you define your alpha? Okay, so you can define product. You can define your null hypothesis. Product is a product or that item is of good quality. Okay,
Oh,
okay, something like that you can define. Now, how you can treat your alpha will be probability of you are rejecting that item. Okay, or that product. Okay, even though given that it is of good quality,
good
right?
call. Correct. Yeah.
Right. That is something I can use this alpha and beta in real scenario. Okay, how will you decide your probability of type 2 error? It will be you have accepted that item. Okay,
Though it is of bad quality.
yeah, correct. It is of bad quality. Okay, now so far it is clear.
Yeah.
Now
Yeah.
in real scenario you can consider this is as okay. Okay, this will be producer's risk or this which one will be producer's risk and which will be consumer's risk?
Okay.
Tell me. If this is the scenario, which one you will consider as a producer's risk and which one you will consider as a consumer's risk?
It is of quality. First one is producer's risk, right? Though
Correct,
it's a good
correct,
quality, we reject it.
correct. It's a producer's risk. Even though product was in good quality, but
Yeah.
it was rejected, and
Correct.
it's a consumer's risk. Okay.
Okay.
Don't worry with the terminology and all. This is not going to be come in your exam, but yeah, just to give a brief idea how we can relate in real life scenario. Okay, so what's 1 minus beta called? Okay, if this is case, that's okay. Beta is what? Probability of accepting H naught, given that H1 is true, right?
H1 true. Yeah,
So
correct.
what will be 1 minus beta? 1 minus beta will be rejecting H naught.
Rejecting H0, but H1 is true.
Means what we are doing here is probability of, if you see, we are rejecting the item or rejecting the product, right?
Yeah.
Given that it is of bad quality,
Okay.
right? So this is something, it seems like power or not, right?
Okay.
Means it's a good thing, right? It should be high, right? You have rejected the product given that it was bad quality. It was in the bad quality, right? That means it should be higher, right?
Okay. If somebody gives in the question, like if power is given and if they ask us to find something like say C or something,
Mhm.
then in that case we should be using the second form, which is 1 minus b equal to reject by if it is a bad quality.
Correct. Okay,
So
okay.
that
So
form
thing
we
is that whenever you will ask find the power of the test or something like that, okay. So there will be one specified value for alternative hypothesis. I mean, it question will be like for let's say mu is equal to 11, what will be the power of the test?
right. Yeah.
Why? Because in sometimes we are defining null hypothesis as let's say mu is equal to 10 and alternative is let's say mu is greater than 10. Okay. But to compute the power of the test, we need H1 here, right?
Ah.
Correct. But what is the H1? H1 is saying mu is greater than 10. Okay.
Correct.
So what they will say, find the power of the test for a specific value of mu when it is 11 or it's a 12, anything, but it will be given to you for
Ah.
this specific value of mu p, something like that. You have to find the
Okay.
power of the test. Got it?
Okay. Okay.
Okay.
So we should take that reject of H0 probability and
Yes, yes,
given
yes. You
as
can
mu equal
you
to
can
1.
keep in mind since by the terminology power. Power
Okay.
means it should be something high. I mean, it should be good. It
Ah.
should be good means you are rejecting that product
Ah.
when it was in bad quality. That way, it's a good decision, right?
Okay. It's a good decision. Yeah.
Good
Correct.
decision, right? Are you getting my idea? Okay,
Yeah. Correct. Correct. Got it.
correct. Okay,
Okay.
fine. Okay. Yeah. Anyone any
Yeah.
doubt from this week 11 solve with this PDF?
One another question, sir. Sorry,
Yeah.
not to solve with us, but on the graded thing, right? I mean, in the graded questions on top, there were some few FZ values were given. Okay, so
Okay.
some of the questions which I was trying to resolve, those were not matching with that FZ value.
Yeah. I will tell you why it's happening. Actually, the graded assignments and all, we
Uh,
have parameterized, right? There is parameterization. What does this mean? It means for every people,
uh,
questions will be same, but you will get the different numbers.
okay.
Okay, suppose I'm saying I have defined h naught mu is equal to 9, but
Uh,
for some people you should it will be let's say 19 or 8 something. But a question is the same, context will be same, but
okay.
numbers will be different.
Okay.
Actually, the values given in the beginning of the question, it's just for few value. Okay,
Okay.
so it's
Okay.
not possible to give all the various. I mean, abject value for all the variations.
Okay.
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 So
Yeah.
regarding graded assignment, you can see from the table or you can find from the collab and
Yeah.
all.
Yeah. I did with Cola, but that's why
Uh-huh.
I'm getting confused
No,
that
no, 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 no. Don't
I'm
worry.
missing
No,
something wrong.
no. It's not about wrong. It's just only about like there were around 100 variations. So we are
Uh,
not able to give 100 abject values for
Got
no.
it, got it. I just wanted to know that. I mean, I'm
No,
not
no,
making
no,
any
no. That's
mistake.
not problem. And don't worry about quizzes and all. You will get the only specific value, those which will be useful for your interim examination.
Okay, sir. Yeah,
Fine?
thank you, sir. Thank you.
Oh,
Yeah.
yeah. Yeah. Anybody else who have doubt from week 11 solve this PDF or
Sir, I
any?
have one doubt, sir.
Yes.
Sir, how can we define test statistics? In the question, we define test statistics, some
It depends on the
function of.
in which I think you had attended the last session.
Yes, sir, I attend.
Okay.
Sir,
Did you? Hmm.
sometimes in the lecture, professor sometimes takes variation, sometimes takes some of
It
the
depends on
samples.
what is the question. It depends what is the question. If it asking about mean, right? Okay. If it asks, let me clarify you to everyone. Okay. I think you should go to this session. I think we had discussed a lots of problem related to this, how to define test and all. Okay. But meanwhile, let me clarify once again. Okay. So thing is that if there is problem related to there are two to three kind of scenario. If problem is like we have to test for mean, okay, Test for mean means suppose null hypothesis is given as mu is equal to something mu naught, and alternative is given to you something mu is greater than mu naught, or mu is less than mu naught, or mu is not equal to mu naught. Okay, so this is something right tail test, right?
Yes, sir.
Okay, and this is about left tail test. Okay, any of this will be there, and this is about two tail test. Okay, if this is case, you okay, so this is the very first case. If we have to test for mean, test for mean means suppose samples are given x1, x2, xn. Let's say these are all IID x or IID normal mu comma some variance. Okay, then we have to test for this mu is equal to mu naught. For example, mu is equal to mu naught, some specific value is given to you. Now, thing is that if this variance is known to us, okay, if this variance is given to us, like for example, x1, x2 up to xn given normal mu comma, let's say 9, for example, okay, then we have to use the Z test, okay, and Z test we will be using, and for this we have to convert. I mean, we can define our test. Test statistics will be x bar minus mu divided by sigma by root 10. It will follow normal 0 comma 1. And how will you decide your test? So test will be for right tail test, it will be x bar greater than c some critical value. I mean, let me write down. Okay, so this is basically called test statistic. Okay, I think you should go through the lectures again, but I will give you some brief idea. Okay, so for whenever you will be having some right tail test, okay, let's say mu is greater than mu naught, so you can define your test. You will reject h naught if x bar is greater than some critical value, some c. Okay, why? Because in right tail test we are doing like this. Suppose this is your z alpha, and if the values are lying in this region, so this is basically critical region, you will reject your h naught. How will you proceed? You can proceed with the alpha. What is alpha? Alpha is probability of rejecting h naught given that h naught is true, and alpha will be given to you whether it's a 5% or 10%. This is probability. What is the when you will reject? So I will reject my x bar is greater than c given that what is h naught? H naught is mu is equal to mu naught. Okay, so what's the next? Now we know this is the G test, variance is given to you, then you can convert this x bar in the form of Z test. Okay,
Normal distribution.
normal, yeah. So basically you can do x bar minus mu divided by sigma by root 10 greater than c minus mu. Okay, now here okay, it will be, let me do like this. Okay, mu is equal to mu. Okay, if x1, x2, xi are normal distribution, right? If these are all are normal mu comma sigma square, then what will be the distribution of x bar? It will be normal mu comma sigma square by n. So we have to convert this x bar to standard normal variate. Okay, so it will be alpha equal to, it will be now, okay, so we have to put the final value of this mu. It will be this case as c minus mu naught sigma by root 10. Now next step, it will be 1 minus, since we have to convert in fz, capital fz, so it will be now this will be z, right? It will be z less or equal to c minus mu naught sigma by root 10. So from here onwards you can solve. It will be z great less or equal to c minus mu naught sigma by root 10. It will be 1 minus alpha. I'm just writing in general. It will be fz c minus mu naught sigma by root 10, okay, equal to 1 minus alpha, and I mean, it will imply c minus mu naught divided by sigma by root 10 equal to fg inverse of 1 minus alpha. Okay, and from here you can find the value of c, which will be mu naught plus sigma by root 10 fg inverse of 1 minus alpha. You can put the value, you can find the value of c. And how we have decided our test? Our test was, I will reject my h naught if x bar is greater than c. Now what you can do, just see this x bar will be given to you, okay, from the sample, and just see, just compare with the value of c. If it's greater than c, you will reject your h naught. If it's less than c, you will accept your h naught as per this condition. Okay, now you can do in reverse order. If h alternative is mu is less than mu naught, then what will be your test? Your test will be, tell me, you will reject your h naught
H
if
naught.
x bar is less than c.
Less than C.
Then similarly you can proceed with alpha. It will be x bar less than c given that h naught. Okay. Then okay.
Sir, if I ask one doubt there,
Hmm.
so first
Sir,
is when you are placing this value in the standard form,
Mm-hmm.
in the denominator, why you are taking sigma by root n? Because it is a sample standard deviation, is it? Yeah, here.
Here.
Yeah, below that.
Okay.
Yeah, there. Right.
Okay, one second. Tell me how I can convert the random variable into standard normal variable?
The mean should be 0, right? I mean,
No, forget about mean. I'm saying I have a random variable x is following some normal or let's say any how I can convert in standard normal format. What's the criteria to making in standardized format?
I see that the formula what you have written, same formula. I mean, I have seen, and then below is the denominator is the standard deviation.
No. Okay. What I'm saying, tell me what's the key rule to convert a random variable into standard normal variable? That is my question. Just tell me. I will tell you from where I we got. Anyone? How will you convert a random variable into standard normal variable?
by subtracting expected value and divided by standard deviation of x.
Correct?
Yeah.
If I have a random variable, I want to convert in, let's say I'm saying x is following normal some mu comma sigma is or whatever. Okay, forget about. How I can convert in standard normal? It will be x minus expected value of x divided by standard deviation of x.
Yeah. Same thing I was telling. Yeah.
Right. So far so good. Now what is your random variable now? It's a x bar,
Sample.
right? Now your
Right.
random variable is x bar, right?
Right.
What is the expected value of x bar? It's a mu.
Yeah.
And what is the standard deviation of x bar?
Standard deviation of x bar is it should be below. It should come the root n, right? I mean,
Yes, in denominator sigma by root n, right?
right.
Are you getting what is the standard deviation of okay?
Okay, I got it. It is for sample, so that's why we are taking sigma by root n.
No, it's not about sample population. Forget about sample population. What I'm saying, suppose I have x is following normal mu comma sigma square. Okay, how will you convert it standard normal? X minus expected value of x divided by standard deviation of x. That
Right.
means x minus mu divided by sigma, right?
Right.
Right. Now, what is the distribution of x bar? What is the distribution of x bar? If I'm saying I have x1, x2 up to x100 or whatever, it's IID normal mu comma sigma square. Okay. And what will the distribution of x bar?
Mu comma sigma square. Mu comma sigma square by.
Arbabe, 1 second. Biplav, are you getting what I'm asking? What will the distribution of x bar? Or what will be expected value of x bar?
Okay. It should be in this case it should be mu, right? That
Okay. How will you get mu? Mu is
so
correct.
it is addition of all the value divided by the number of sample, right? It is
Correct. Means basically x bar is nothing but x1 plus up to x100 divided by 100. Or simply let's say it's n. I'm talking about let's say in general, right?
correct.
It will be n mu divided by n. So you will get mu. Correct.
Right.
Okay. Now what about variance of x bar?
It is sigma square. That
Only sigma square.
variance of x bar sigma square by n, right?
It will be 1 upon n square, right? And variance of each xi because all are IID, right? Correct.
Right.
Okay. So numerator part will be sigma square plus so on plus sigma square divided by n square. n times sigma square divided by n square. One n will get cancelled out. Now it will be sigma square by n.
Right.
Right? Now x bar is following normal with mean mu comma sigma square by n.
Right.
Correct? Now,
Yes.
what is the criteria to convert in standard normal form? It should be x bar minus expected value of x bar divided by standard deviation of x bar.
Right.
Now, x bar is your another random value. Let's make it y. So, what is the expected value of x bar now? What is the standard deviation of x bar?
Sigma by root n.
That is same thing I have done.
Correct.
Now it's clear.
Yeah. Yeah.
Okay. Yeah. Fine. Okay, so we were discussing some those kind of tests. Okay, so as per the whether your alternative is defined in right tail test, left tail test, and two tail test. Accordingly, we will decide our test, and then we proceed with alpha or something like that. Okay. Okay, so is there any doubts from this solving as PDF, or should we move to the week 12 content?
Sir, the previous example, what you were showing, I just have got one more doubt there. You told that when the mean is greater than the C, right?
Hmm.
So in that case, it is we will reject, right?
Here, this one, yes.
Yeah. So when we are solving this kind of problem, in one of the lecture session, it is Sarah has explained, right? The type 1 error and type 2 error. Is there any correlation with that? Because in the type 1 error, it says reject H naught, but when the H naught is true, when we are solving this kind of problem, does it have any kind of correlation with type 1 and type 2 error?
Okay, so basically, yeah, there is a correlation because I told just a few seconds before this example, right? Did you get this?
I joined when you were the last portion, but anyway, if it is discussed, then I will go through it.
Yeah, just go through in the initial part. So basically, see, type 1 error is nothing but probability of rejecting something when H naught is true. Okay, I took one example. Suppose there is one manufacturer owner of a company, something like that. Okay, there is some product is manufacturing in that company. Suppose I have defined my H naught, its product is of good quality. Okay, then alpha is defined as probability of rejecting H naught when H naught is true. Okay, so how you can define your alpha? Alpha is, let's say I'm saying probability of I will reject that product, that item when given that it is of good quality, right? And what is the beta? This is called, say, these two kind of, if you see by this example, you can relate very easily. In real life scenario, this kind of error happens, right? Suppose beta, it can be happen, right? You have accepted that product even though it was of bad quality.
Correct.
Correct. Alpha, you can do. I mean, there is a probability of happening this kind of error. You have rejected that product even though given that it was of good quality, right? Okay. So that is something we have to keep to minimize these kind of errors actually. Okay.
Okay.
Yeah. Fine. Got
Got it.
Okay. Yeah. Correct. Fine. Okay. So any doubt from week 11? Should we move to the week 12 content? Fine. Fine. Week 11. Okay. Okay. Right. I'm moving to the week 12 content. Okay.
Yes, sir.
Okay. Okay. Just give me 1 minute. I will be back in 1 minute. I will start. Okay. So, I mean, till in week 11, we have seen some tests related to that. If we have some sample, right? If I'm interested to test for mean, so there are two tests, Z test and T test. Okay. T test I will prefer when variance is unknown to us, then I will go with the T test, right? And okay, if I'm interested to check the variability of that data set, then there is chi-square test, right? For one single sample. Okay, till this point, everything is clear? Yes or no? Hello? Is it?
Yes.
Yeah, till chi-square test, single tail test, is it clear to everyone, right? Am I audible?
Yes,
Yes,
sir.
sir, you are audible.
Yeah, so I'm asking till chi-square test, is it clear, or if I will move, then I mean, then I will move to the two
Hello,
sample
sir.
test. Yes.
Sir, I have a doubt from week 11. Can I ask you now?
What is your doubt?
Sir, I saw that in few questions, sir, just select the state statistics as x bar, that means mean, to find the mean. And in few cases, sir just added those variables and select this as a test statistics. When I need to take these test statistics as a mean, and when I need to just do the addition.
No, no, it's okay. So if question is okay, so if your hypothesis is related to something, let's say I'm saying H naught is about mean, right? Okay, I'm interested to test for mean. Okay, so just go with the X bar greater than some C or less than some C as per your alternative hypothesis. If there is some question related to, let's say, proportion, right? Probability of, let's say, some success probability, or there is some defective items, you have selected some 10 items, out of them, let's say 3 are defective, something like that. Okay, so in that scenario, what you can do, you can go with the numbers, summation of each xi. Okay, this is one way, or you can go with the x bar also, no problem. In both cases, you can go with the only the thing is that if suppose this is something Bernoulli, all xis are Bernoulli, then it will be binomial, right? It will be, let's say, 100 p and 100 p 1 minus p. For example, there are some 100 samples. Okay, so in this case, your expected value will be 100 times p, right? And variance will be 100 p into 1 minus p. Okay. Now, if you are taking, suppose you're taken x t is greater than c, then you have to convert by using this expected value and by using this variance. If you have taken x bar is greater than c, then your x bar will be, it will be something approximately normal. It will be p comma p into 1 minus p divided by 100. Okay, so you can go with anyone. At the end, you will get the same answer. Okay.
Oh, okay, sir. Okay.
Yeah, yeah.
Uh,
Okay.
Sir,
So,
where
hmm,
the PDFs of these lectures are in which section?
PDFs of this lecture.
On course statistics course, where are the
I think
PDFs
you
of
okay. You got the answer on this course itself, right? If I'm not
this
wrong.
course? Okay, I will check.
Okay, just check. It's in week 10. Name is week 10. Okay. Okay, so tell me. Okay, so this look. Okay, let's go
No, no, sir.
in.
The PDF of live sessions you are taking.
Okay, it's not uploaded. It's some messy condition. Okay, we have not uploaded it. Okay. Okay, so till this point, t test for, I mean, this test for mean is clear to all of you. Okay, from the week 11 content.
Yes, sir.
It's clear, right? Z test, right? Okay. What about t test? Then variance is unknown. Okay. First of all, let me ask to everyone some questions. Okay. Tell me how many like test is clear with you. Week 11 is okay for everyone.
Yes, sir. Week 11 is okay, sir.
Okay, what about week 12?
Not started, sir. Yet. That's why didn't understand.
Okay, what about others?
So week 12 is yet to be started, sir.
Okay.
So maybe the week 11 content is too heavy. I mean, lot is there and time is very less.
That's okay, but thing is, if we are asking something, you can respond it whether you got the thing or not. Otherwise, we will assume everyone got the idea, right? So if you not speak anything, I don't know. Like I will assume you got the idea, and I will just simply solve some question, and I can end the session. Right? If you want
Maybe.
some, so accordingly you can tell, right? In the last session, I think I have discussed some tests related to, I mean, which are already in week 12. Okay. So if you are not, if you did not get the idea behind that, you can simply ask, we did not get or something like that. Okay. So feel free to say. If it's not like, then we will assume everyone got the idea, and we can release the PDF and all with solution.
No, sir. I personally could not finish week 12, so.
That's okay. You can simply tell me, right? Okay, no problem. Okay, so first of all, week 11 is okay, right? So in week 11, we have seen some, only one test, that was test for mean. Okay, I will go through with the rough idea. Okay, so we have seen one test called test for mean. In this case, what is the scenario? It's like suppose my null hypothesis is defined as mu is equal to some specific value of mu naught. Okay, and alternative is it can be something mu is greater than mu naught, or mu is less than some mu naught, or mu is not equal to mu naught. Okay, now, accordingly, I can define my test, right? As per my null hypothesis, I will define my test. If x, I will reject h naught if x bar is greater than some c, or x bar is less than some c, or if it's two side, I will say x bar minus mu is greater than some c. Accordingly, right? Now, this is something we have done, and we know we have to. We will start with the alpha, and it will be probability of rejecting h naught, given that h naught is true. And thing is that, so as per our test, let's say I'm taking this first one, and mu is equal to mu naught. So thing is that we have to convert in standard normal from here, right? And accordingly, I will at the end, we will we will find the value of c. I mean, you can see I have done just few minutes before, right? Like this, I will find the value of c, and the x bar will be given in my sample, and accordingly I will compare as per my test, and I will take the decision, right? So for this idea is okay in case of test for mean, when variance is known, right? Right, variance will be given to us. Let's say x1, x2, so on, xn. These are normal distributed with mean, mu, variance 9, something like that. Okay, this is the problems related to this kind of scenario we have done in week 11, right? Till this point, it is clear to everyone.
Yes, sir.
Okay, now suppose what if variance is unknown to me? Okay, that might be a case, right? If so there is called t test. Okay, so I will prefer t test for mean. Okay, when variance is unknown to me. If variance is unknown to me, then I will start with the, I will go with the z test, otherwise I will go with the t test. Okay, the same case, to test for the mean. Let's say I'm saying x1, x2, so on, this is xn, these all iid normal, mu comma sigma square, right? This is unknown, this is not given. If this is given to us, we can simply proceed with the z test, right? Right, we have to convert in x bar minus mu divided by sigma by root 10, and at the end we have to find the fz value, right? What if variance is not given to me, right? If variance is not given to me, we will proceed with the t test. Okay, how will you define test? I will tell you. Just let me define the null hypothesis. How we'll define in null hypothesis? It's a mu is equal to, there will be some specific value of mu, right? Mu naught. Okay. And let's say alternative is given to us, mu is greater than mu naught. Okay. I'm just taking a right tail for now. Okay. So what will be your test? Tell me, as per your alternative hypothesis. I will reject my H naught when
X bar is greater than C.
X bar is greater than some C. Fine. Now, so since we know here this, okay, if this population variance is unknown to us, so one thing we know, expected value of sample variance is what? Sigma square. Right? We have done, right? I think in week 7 and all. This means what? In week 9, we know unbiasedness. This S square is an unbiased estimate of this population variance, right? Are you getting? So basically, this is an unbiased estimate of sigma square. I mean, this sigma square is not given to us. Then I will be using an estimate of this sigma square, which is S square. Okay. So in the place of sigma by root 10, we will go with the S by root 10. So T statistics is defined as, it's nothing but, it's defined as X bar minus mu divided by S by root 10. Okay. So it's the same. I mean, it's same. Just the only difference is variance is not given to us. Okay. And it's called, it will follow some T n minus 1 degree of freedom. Okay. This is called n minus 1 degree. For for now, you can keep in your mind. We will discuss in depth for this degree of freedom and all. Let's focus on test first. Okay. So, okay. So now, okay. So basically, if you see here, we are going to use the sample variance rather than sigma, because sigma is unknown to me. Okay. Procedure is same. Okay. So you know, we have decided this X bar is greater than C, right? Okay. What is the procedure? I will go with the alpha. Alpha will be given to us. What is the alpha? Alpha is probability of rejecting H naught given that H naught is true, right? Alpha, okay, what is the reject, when you will reject? X bar is greater than some C and H naught is, let's say, mu is equal to mu naught. In this case, if you see, X bar is what? If X1, X2, yeah, the same content we have to apply. If IID normal mu comma sigma square, right? Then what will be the distribution of X bar? It will be normal mu comma sigma square by n, right? Yes or no?
Yes, sir.
The same thing we have to convert in standard form. Now it will be X bar minus mu. I'm using direct mu naught. Okay. Divide by sigma by root 10 or divide by S by root 10?
S by root 10.
S by root 10, because this sigma square is unknown to us in this case, right? Okay. So it will be S by root 10 greater than C minus mu naught divided by S by root 10. Okay. So now, okay, this, what should I write for this quantity? Initially, we were writing this is as a Z, right? Now, this is not a Z. If you see, this is Tn minus 1, right? So basically, this will follow Tn minus 1 greater than C minus mu naught divided by S by root 10. Okay. What is degree of freedom and all? We will discuss it later. This is something, why it's n, not n, why it's n minus 1, because 1 degree of freedom we are losing, we are losing 1 degree of freedom to estimate these parameters actually. Okay. We will discuss it later. Let's focus on
in the second line, I'm missing something simple. You are saying that reject H naught given H naught, right? H naught is true.
Correct.
In the below line, that there you are, why you are saying mu is equal to mu naught?
Because H naught is defined like this. H naught is true. That means I have to use mu is equal to mu naught. Okay.
Okay.
Are you getting?
Okay, so we are saying that reject it if it is X bar is greater than C, but
this is criteria of rejecting, right?
Correct.
And H naught, I'm saying there is one specific value of mu is given to you. I mean, see, this is something hypothesis we have defined. For this hypothesis, I'm going to check my test. That's all. I will be using this value, specific value of mu or p, whatever, as per the hypothesis. I will proceed for my test. Okay.
So it is given that mu is equal to mu naught, and
Yes,
we are
yes.
testing that x bar is greater than c.
Yeah, yes.
Okay. And if
I
it
mean,
is so, then we reject the
have you,
h naught.
okay. One question. Have you seen the week 11 content or not?
Yeah, I've gone through it.
Yeah. Okay, yeah, that's correct. The same thing we were doing. Okay. Initially, it was just J test because sigma is given to us, right? Now it's not given to us. Okay.
Okay.
Fine. Now, so what's the next step? We have to convert in FZ form, right? Not FZ. Here it will be FT. So to convert in CDF, so I have to do less or equal to, right? It will be n minus 1 less or equal to C minus mu naught divided by S by root n, right? Here I'm doing in general. I will take one example related to this. Don't worry. So it will be alpha. It will be 1 minus f t n minus 1 c minus mu naught divided by s by root n. Okay. So now what I can do next? I can do f t n minus. Okay. This is something you got, right? How I converted in the CDF. Yes or no?
Yes.
So it will be 1 minus alpha. So from here, I can simply do C minus mu naught divided by S by root n. It will be F T n minus 1 inverse 1 minus alpha. Okay. So don't worry about these value. We will provide. Okay. If there is any question related to this. So basically C, we have to find the value of C. So it will be C minus mu naught equal to S by root n F T n minus 1 inverse 1 minus alpha. It will be C equal to mu naught plus S by root n F T n minus 1 inverse 1 minus alpha. So by putting all the values and all, we will get the value of C, right? And we will, there will be value of X bar. Now, we had decided I will reject H naught when X bar is greater than C, right? So from here you will get value of C. From here, from the question, from the sample, you will be having the value of X bar. Now compare. If this is the case, you will reject, or else you will accept your null hypothesis. Okay. Some sort of rough idea is okay. Yes. No?
Yes.
Okay. Okay. Let me take one example. Okay. Let me take. I think there should be some questions related to this chi-square problem. Yeah, let's come to this part. Okay. If you see what the question says, the manufacturer of a new car claims that a typical car gets a mileage of 36 kilometers per liter, right? Okay. We think that mileage is less. To test, okay, if mileage is less, what will be your alternative? Okay, alternative is given itself, no problem. So to test our suspicion, we perform the hypothesis test that alternative is mu is equal to 36. Sorry, null is mu is equal to 36. Alternative is mu is less than 36, right? Now, suppose we take a random sample of 100 new cars and we find their average mileage is 36.4. Okay, what is this 36.4? This is
X bar.
X bar, right?
X bar.
Okay. And sample standard deviation is 4. That means this is given as S, right? Yes or
Yes,
no?
sir.
Correct.
Yes, sir.
If you see in the beginning, there is not, we don't have any information about population variance. We have information about only sample variance, right? That means,
Yeah.
and if you see how your null hypothesis has been defined, it's for mu, right? It's for mu, and sigma square is unknown. I mean, sigma square means population variance is unknown to us. We have given only sample variance, right? That means we have to use the t test for mean. Yes or no?
Understand, yeah.
Understood? Now let's come to one different question, whether Z test is there. I think there should be. Let's come. Okay, now if you see this question, in this question, what question says? It is claimed that lifetimes of light bulbs are normally distributed with mean 100 hours and standard deviation of 2 hours, right? So this is sigma given to us, and this is mu is given to us, right? Here sigma is given to us, right? We know, and I mean it's a given information, right? And if you see your null hypothesis, it's nothing but mu is equal to some mu naught is 100, right? So if, okay, so this is something here, variance is known to us. That means here we have to test for mean. Since variance is known to us, that means I will be using the Z test. Are you getting? Are you able to see the difference between these two?
Right, sir. When the variance is given, we have to go
Correct.
with the
See,
Z
case
test.
is same. See, question is same. We have to test for the mean, but we have to keep in mind if variance is known to us, I will prefer the Z test, or else I will prefer the T test. Clear? Okay. Should we go to this question solution part?
Yes, sir.
Okay. Now, so if you see what are the information given to us? H naught. Okay. Okay, I will explain from here itself. Okay, will that be fine? Okay.
Yeah, fine, sir.
Yeah. Okay. So alpha is given to us 5%, right? And x bar is 36.8. Now, what is the null hypothesis? 36, and alternative is less than 36. Okay, I took one example. I mean, one alternative. Sorry, alternative. I took mu is greater than mu naught. Then I defined my test. Okay, if I have mu is greater than mu naught, for example, okay, for any specific value, then what will be my test? I will reject h naught if x bar is greater than c, right? Here, if you see, your mu is less than some mu naught, right? Yes or no? A specific value of mu naught. Then my test will be, I will reject my h naught if x bar is less than c. Correct? Now, in the question, x bar is given to me. I will find value of c if in reality, if c, I mean x bar is less than c, I will reject, or else I will accept it. So far, so good? Yes or no? Are you getting idea, right? Yeah. Is it clear or?
Clear, sir.
Clear? Yeah, do let me know if, okay. Now, what's the next? Next step is I will proceed with the alpha, right? And what alpha says? Alpha is nothing but probability of rejecting H naught when H naught is true, right? And what is the reject when you will reject H naught? We have decided I will reject H naught when X bar is less than C, right? So I will alpha will be probability of rejecting H naught, which is X bar less than C when H naught is true, and mu is nothing but mu is equal to 36, right? Since we know this is something variance is unknown to us, I will after this I have to convert in standard form, right? Standard one is standardized format, right? Then, so how will you convert? So x bar minus, okay, what will the distribution of x bar here? It will be normal 36 comma s square by n, right? Why I'm using s square? Because sigma square is unknown to us, right? So x bar minus 36 divided by square root of s square by n. That means simply you can write it s by root 10 less than c minus 36 divided by square root of s square by n. Now this term will be, okay, tell me how will you write this one? I told you initially
Tn minus 1.
it will be t n minus 1 means what? 99, right? Okay, so if you see, it will be, okay, now it's already in less than form, so I can write capital ft 99 c minus 36 divided by square root of 16 divided by 100. Yes or no?
Yeah, okay, yes.
Okay. Clear? So this is 0.05 ft 99 c minus 36 divided by square root 16 by 100. So will we find, okay, so from here it will be ft 99 inverse 0.05 equal to c minus 36 divided by square root of 16 by 100, right? Then now I can find the value of c, right? In the question, this is provided, this has been already provided. If you see ft inverse, this value we have already provided, and I will put the value, and we got the value of c as 30.5 35.336. Okay, now x bar was 36.4, c we got 35.336, 6. But we decided our test, I will reject when? If x bar is less than c, right? That was the my case, right? Test, right?
Yes, sir.
But in this case, if you see, x bar is greater than c, right? So it's a reverse, it's the opposite case. So that means I will accept h naught. Is this clear?
Yeah, sir, in the
Yes, sir.
question, is it mentioned that we have to start with that x bar less than 6, less than c?
See, that is something you have to decide, right? See, okay, what I told, if you're, okay, what, you decide by your hypothesis.
Okay.
See, think you have not seen the content very carefully. Suppose this is h naught is mu equal to mu naught, okay? Alternative, suppose mu is greater than mu naught, okay? This means what? I'm talking about right tail test. Yes or no?
Right.
Okay. Okay. Alternative can be mu is greater than mu naught, or mu is less than mu naught, or mu is not equal to mu naught, right?
Mm-hmm.
There are three kind of tests. Okay. What I should prefer, I will prefer you just rewatch the content of open session which we have discussed on Sunday. Okay. Let me clarify first of all. So this is basically Z alpha. This is called the critical value. Okay. This is Z equal to 0. This Z means standard normal form, right? I will reject in case of right tail test when my this is called basically critical result. If things are lying here, okay, if things are greater than this, I will reject. Okay, are you getting?
Yeah, okay.
Now, so if your null hypothesis mu is greater than mu naught, that means my test will be you will reject h naught when this is right tail test, right? You can keep in mind by the sign itself. Greater than means right tail test, less than means left tail test, something like that. Okay. You will reject your h naught when if your sample mean is greater than some c. I mean your sample mean is lies in this area greater than this value. Okay. Now if h naught, if suppose alternative is defined as mu is less than mu naught, right? That means what? This is bell-shaped curve. Just assume this is bell-shaped curve. So this is something minus z alpha. Okay. So if my values are less than this point, I will reject, right? So my test will be what? I will reject h naught if x bar is less than some critical value. Okay. So based on your hypothesis, you will define whether your x bar is less than c or greater than c, or whether it's modulus of x bar minus mu greater than c. Okay.
Okay.
If it's two-sided, mu is not equal to mu naught, then your test will be you will reject your h naught if modulus of x bar minus mu is greater than c. Okay, this means x bar is greater than some mu plus c, or x bar is less than some mu minus c. Okay, so here if you see in this part, my alternative was mu is less than 36, right? I'm talking about less than. That means I'm talking about I will take the decision about my this region, right? So I will decide my test. I will reject my h naught if x bar is less than some c. Okay, clear?
Okay.
Fine. Okay, so this test of mean for is clear to everyone.
Yes, sir.
Okay. Now what about suppose okay, so far we our hypothesis was defined in terms of mean. What about if I want to test for variance? Is there any test for variance?
T-test.
T-test. Are you sure?
Kind of, sir.
No, no. Actually, T-test we are using for checking the mean. Okay, not for variance. Okay. So, so test for, I mean, there is one test called chi-square test for variance. Okay. What's the idea behind it? Let me clarify, give you some rough idea. Suppose I'm saying x1, x2. These all are IID normal. Okay. Mu comma sigma square. Okay. Suppose rather than okay, so we so far we have defined h naught as mu is equal to mu naught, h as mu is greater than mu naught, or mu is less than mu naught, or mu not equal to mu naught, something like that. Okay. Now, if what about if my h naught is, suppose I'm interested to check variability of my data set. So I can define H naught as a sigma equal to sigma naught. Yes or no? And alternative will be, let's say sigma is greater than some sigma naught. Okay. Now, so there is one concept, whether I'm not sure whether you are aware about this or not. So I'm just writing the test statistics directly. Okay. By seeing this alternative, how will you? What will be your test? I will reject H naught when. Tell me, just think. If mu was greater than mu naught, your test was reject H naught if
less than C that time.
less than. If I'm saying if H naught is mu is greater than mu naught, not H naught, alternative is mu is greater than mu naught. How? What will be your test?
It is greater than. I mean, the previous one we have seen, right?
Greater than. That's okay. How will you decide your? How will you define your test? What you will write for? You will reject your H naught when?
When the mu is greater than C.
Mu is greater than C. Just think. I will talk. See, we want to test for the population parameter. See, mu is the something population parameter. We don't know, right? We will check with the sample data. So we have to write mu is greater than C or something else. Anyone? Tell me. See, my claim is I'm saying mu is something mu naught. Okay. I think you are not thinking a little bit also. See, I'm claiming I'm making some hypothesis. Mu is something mu naught. Okay. I'm claiming this thing. Okay. If you see, if you read the question carefully, what is claim? Mu is 36, right? Claim of the manufacturer is car gets a mileage of 36 kilometer per liter. Now you wanted to check by taking a sample, right?
Right.
Right. See, that manufacturer is saying that mu is 36, mileage is 36 kilometer per hour. This is his claim, right? Alternate, you suspect, and alternative is mu is less than 36. If mu is less than or something, let's say mu is greater than, then how will you decide your H naught? Sorry, test. I decide I will reject his claim if mean of the sample data will be greater than some value or not. As per this hypothesis, you decided sample mean is greater than some C. Yes or no?
Correct.
Correct. See,
Yeah.
claim will always be in terms of parameter which we don't know. I mean, I'm saying I have made a claim. I will test that claim based on the sample data. Okay. Now for mean, I have used the sample mean. Now tell me for this case, how will you decide? You will reject your test now, reject H naught when? Just think, just says, feel free to say whether it will be wrong. We can discuss.
In terms of sigma, we have to say, or in terms of any constant, we have to say.
Okay,
I mean,
just see this value. Just see this. If H A is mu is greater than mu naught, how I'm deciding my H naught? Sorry, test
x bar greater than C.
Greater than C. If alternative is like this, so what will be your test? See, I mean, I will check my claim about my population mean by the sample mean.
Right.
Correct. So what about this? Just think.
This variance. I mean, it is a spread given. I mean,
It's a spread given. Yes, fine. Just think. Okay, see, you know, mean sample mean is and by estimate of population mean.
Correct. It is.
Sample variance is an by estimate of population variance. Right. See, if you see here, to check the population parameter mean, I use the sample mean, right, to check that claim. If it's about population standard deviation, population variance, so, I should check S is greater than some C or not, right? S is the sample standard deviation here itself. Are you getting?
Yeah. Okay.
That was my question. See, just think little bit, right? It's everything you can find on, but okay. So what? Okay. So in case of mean, if you see, this is something we have done, right? Then what? How will you decide your test? You will reject H0 if X bar is greater than some C. Here I'm talking about standard deviation or variance, you can say, right? I have made a claim, sigma is some sigma naught, or sigma square is some sigma naught square. You can take, no worries. Then similarly, I will test. My test will be, I will reject my H0 if X bar is greater than C. Okay. So there is one called statistics called chi-square. So I will tell you what's the form of chi-square. So it's nothing but n minus 1 into s square divided by sigma square. It is follows chi-square with n minus 1 degree of freedom. Okay. So this is basically chi-square statistics. It's called chi-square statistics. Okay. So initially you have seen this one, right? X bar minus mu divided by s by root 10. This kind of form, it's called Tn minus 1, right? So this kind of form, actually you can search about it. Okay. So for now, I'm focusing on the test. Okay, basically. Okay, so under H0 means when sigma is sigma naught. So I can write n minus 1 s square divided by sigma naught square. It will follow chi square with n minus 1 degree of freedom. Okay, so this is test statistic. Now, so if we have to test like this, okay, so we know what will be my test. I will reject my H0 if S is greater than C. Okay. Now, what is the criteria? I mean, what is the next approach? What we have done so far? We have to compute the alpha. See, to test this, whether, see, first of all, this S will be given to me and this sigma naught will be given to by our hypothesis, by our claim, right? So thing is that I will be interested to check whether this S is greater than some C or not. Yes or no? Correct. So alpha is what? Probability of rejecting H0 given that H0 is true. Okay. Now you will tell me alpha is, what should I write now at the place of rejecting H0?
You can initially write S greater than
S
C.
greater than C. Correct. Very good. And H0 is, we have seen, let's say sigma is equal to sigma naught, right? Now, so okay, in the previous part, what we have done, if you see here, what we have done after writing this, if it's, I know this is variance unknown, then I will convert in T form of the T statistic, right? Okay, but now we have some thing about something information about variability, right? Then I have to convert these things in chi-square. Yes or no? So it will be alpha is equal to, so simply I can write S square is greater than C square, given that sigma equal to sigma naught. I can write or not? If two,
Yes.
okay. Now we know, just keep in this statistic in your mind. Okay. So alpha equal to probability of, okay, before this, I know n minus 1 S square divided by sigma square is following chi square n minus 1. Okay. Now, if you see S square greater than C square, now we have to convert in chi-square form. So it will be, I have to multiply both sides with n minus 1. Yes or no?
Yes, sir.
Right? I have to divide by sigma square. Yes or no? So alpha will be, and sigma is given to us some specific value, sigma naught. So it will be n minus 1 S square divided by sigma naught square greater than n minus 1 C square divided by sigma naught square. Right? So alpha will be now, what about this term? This is nothing but chi square with n minus 1, right? And this will be greater than n minus 1 c square divided by sigma naught square. So far, so good. Any doubt?
No.
Till this point, you are able to relate, right? How we can convert in the respective statistics. Now we have to convert in CDF. So to convert in CDF form, I have to do less in less than side, right? So it will be chi square n minus 1 less or equal to n minus 1 c square divided by sigma naught square, right? So this part will be 1 minus, it will be capital F CDF of chi square n minus 1 in bracket this value n minus 1 times c square divided by sigma naught square, right? The same procedure, only difference is as per our claim, whether it's about variance or mean or something like that, we have to convert in the in the form of respective test statistics. Okay, now so from here I can do f chi square n minus 1, okay, n minus 1 c square divided by sigma naught square equal to 1 minus alpha. Yes or no? From here I can do n minus 1 c square divided by sigma naught square as f chi square n minus 1 inverse of 1 minus alpha. Yes or no? So basically from here I can find the value of c square, right? Sigma naught square divided by n minus 1 f chi square n minus 1 inverse 1 minus alpha. So this value will be given to us. Okay. So now we have value of c square, right? Now we know, we have decided I will reject our test. I will reject my h naught when s is greater than c, or you can simply say s square is greater than c square, right? So this s square will be given in the question, I mean, or you can find from your sample data, and this c square you have I mean, by substituting all the values, you will get the value of c square, and just compare whether this is true, then you will reject h naught. If this case is not satisfied, that means you have to accept your h naught. Okay, so far rough idea is okay. You got the idea how we can convert in the form of respective test statistic. Then I will move to the question related to this. Did you get the idea? Yes or no?
Yes, sir.
Okay, fine. So let's move to this part. Okay, now you will be able to read. Okay, just read the question. Question says, in the past, standard deviation of weights in grams of salt packages filled by machine was 40. What is this 40?
Standard deviation.
Standard deviation what? Whether population or sample? It's given us some previous information, right? Are you getting? So this is sigma naught, right? Or you can simply guess with your hypothesis also. Okay. So my hypothesis is basically I'm saying sigma is 40, right?
Right.
Now just read the statement. It will be very clear to all of you which test you to apply. Now, to decrease the standard deviation of weights, a new machine is introduced. Okay. A random sample of 25 packages from the new machine showed a standard deviation of 32. Okay, now we have random sample of 25 packages, and we got a standard deviation of 32 by this random sample. That means I have sample standard deviation as 32. Yes or no?
Correct.
Correct. Now, what question says, based on this data, see by what are the quantities given to you, you can get the idea from there what kind of test you have to apply. Based on this data, what is your conclusion at a significance level of 0.05, that this is alpha, on the standard deviation of weights of salt packages filled by the new machine? Question is saying standard deviation of weight is 40, standard deviation of weights is less than 40. So I'm talking about h naught is sigma is equal to 40, and alternative is sigma is less than 40. Now hypothesis is about standard deviation or population variance. right? And we have given n as 25, s as 32, correct? And this is about variance, single sample. Then I can use the chi-square test statistics. Yes or no? Because we know chi-square nothing but n minus 1 s square divided by sigma square is following chi-square n minus 1. And this is given to me, this is given to me, this is something I can find with the my hypothesis. So far so good? Yes or no? Are you getting? Okay. So this H naught is sigma is equal to 40. HA is sigma is less than 40. So if you see, this is okay. Initially I took sigma greater than sigma naught. Then I decided test as S is greater than C, right? I will reject H naught if S is greater than C. But here if you see, if sigma is less than 40, then your test will be, you will reject H naught if S is less than C, or S square is less than C square. Anything is fine. Okay. So now, okay. So we know n minus 1 s square divided by sigma square is following chi square n minus 1, and we have n as 25 in the sample is given to me. So it will be chi square 24. So it will be 24 times s square divided by 40 square chi square 24. Okay. So let's continue with the our procedure we are doing with the alpha. Okay. Okay. Till this point, is it clear to everyone? Any doubt? Yes, no? It's clear. I'm assuming if you're not sure, right? So, okay, we have to proceed with alpha. So, what is the alpha? Alpha is nothing but probability of reject H naught when H naught is true, and alpha is what? And when we have decided I will reject H naught when S square is less than C square. So, S square is less than C square is alpha. This is alpha now. So now basically what the steps we have done here, S square is less than C square given that sigma is 40. Now we know n minus 1 S square divided by sigma naught square will follow chi square n minus 1, right? So we have to do n minus 1 S square divided by sigma naught square less than n minus 1 C square divided by sigma naught square, given that your sigma is 40, right? So if you see, this is what? Now n is 25, right? So this will be chi square n minus 1, that means 24 less than 24 C square sigma naught is 40 square. This is something, and this is alpha. Alpha is 0.05. So I mean, this value is given to us in the question. I mean, this value, if you see, F inverse of 0.05 of a chi-square distribution at 24 degree of freedom is 13.85. Okay. So from here, if you see, it will be basically, it's nothing but F of chi-square 24. Okay, 24 C square 40 square is 0.05. So it will be 24 times C square divided by 40 square will be F inverse chi square 24 0.05, and value of this is 13.85. Okay. So from here, by solving, we got the value of C square. Now if you see, S square is 1 not 24, C square is 923.33. We decided I will reject H naught if S square is less than C square, but it's a reverse order. So now by calculating, we got S square is greater than C square. So that means I will not reject the null hypothesis. That means I will accept the hypothesis. That means hypothesis was sigma is equal to 40. That means you will say standard deviation of weight is 40. Okay. Is this clear?
Yes, sir.
Okay. You are able to get now you are getting the idea in which scenario you can use the which kind of test, right? Till this point, things are clear. To test for mean, to test for the variance.
Yes, sir.
Okay. Now, what about, so far we have discussed about single sample, right? What about you will have when you will be having some two sample? How will you proceed then? right? That can be a question, right? Yes or no? Okay, I was there. Okay, so far we have discussed for single test only, right?
Sir, in the exam, this all these formulas like will be given or it will
Yes,
be.
yes. Every test. Okay, see, every distribution, every test will be provided to you. Only thing is you have to be clear with your concept, like in which question, which kind of test you have to use. Okay. Don't worry about formula. This test is statistic n minus one s square divided by sigma square and all. Everything will be given in a formula sheet. Okay. All kind of distribution, all kind of inequalities along with their PDF, PMF, CDF and all expected value variance and all. The only thing, I mean, you have to clear with your concept. I mean, in which case you have to apply. That's something you have to clear with that. Okay.
Sir,
So basic thing is you have to. I mean, you should be able to differentiate. Yeah, this is the test for me. I have to test. So basically, you can decide from your null hypothesis and alternative hypothesis.
sir,
Okay.
can you please share the latest formula sheet?
You can find the previous term also. Formula sheet is the same.
No, sir, because the one uploaded right now has Chebyshev's inequality at the last.
So that might be quiz too, right? For n term, you can check from the previous term, okay? Or
Okay,
else what we will do when I will release the mock for n term, right? We will release the respective formula set also. You will get the idea, okay?
okay, sir. Thank
Fine.
you.
Oh, fine. Okay. So so far, test for single mean, test for variance for single sample. It's clear to everyone, right? So let's move to the two samples, okay? Whenever you will be given two samples, then how will you proceed, okay? Okay, so suppose I have given x1, x2 up to xn1. Okay, so this is let's IID. So normal distribution with, let's say, mean is mu1, variance is sigma 1 square. Okay, and another sample is y1, y2 up to yn2. This is IID normal mu2 comma sigma 2 square. Okay, and these two are independent. Okay, now, okay, tell me by the previous information, what will be the distribution of x bar by the given information? Yeah, tell me what is the distribution of x bar?
Distribution of x bar.
Yeah, it's a normal, but I'm asking about mean and variance.
Okay. So it is all the addition by the number of sample divided by n, right? I mean,
Yes, yes, yes. See, some things you should keep in mind, right? I mean, if x1, x2, xn are IID normal mu comma sigma square. I mean, you can compute also, right? We have just computed. Can you check what is the expected value of x bar?
it is
Mu,
mu.
right? So
Yeah.
for this case, what it will be? It will be mu1,
mu1.
right? What will the variance?
Variance will be the sigma square. In this case, sigma 1 square.
That's all.
It is
By n.
sample by n, yeah.
Correct? By n1.
Yeah.
And what about distribution of y? Same. It's a
Yeah.
normally distributed mu2 comma sigma 2 square divided by n2. Right?
Right.
Now, tell me, okay, just be clear with this kind of concept, okay? I mean, this kind of clarification is important. So what about x bar minus y bar? If I'm saying it will be normally distributed, what will the mean and variance?
Mu1 minus mu2
Okay,
and sigma 1 square minus by n1 minus sigma 2 square by n2.
okay, is this correct? It should be right. It's correct. Let's verify. Okay. So expected value of x bar minus y bar, it will be expected value of x bar minus expected value of x bar, right? And it's a mu1 minus mu2. It's correct. Fine. Variance of x bar minus y bar. Okay. So these two are independent samples. So I can write variance of x bar minus variance of y bar, right? This is something I should write. Correct?
Yes, sir.
Okay. Okay. Tell me what about variance of it should not be something like that plus. Yes or no? See, variance of x bar minus y bar, I can simply write variance of x bar plus minus 1 times y bar. Okay. So variance of x bar plus minus 1 square variance of y bar. So basically this will not be minus, it will be variance of x bar plus variance of y bar. Okay. So keep these things in mind, these minor mistakes. Okay. It will not be minus, it will be positive sign. Okay.
Okay, sir.
So this will be sigma 1 square divided by n1 plus sigma 2 square divided by n2, right? Now, tell me, we have done for single sample, right? So what about n1 minus 1 sx square divided by sigma 1 square? It will follow chi square with n1 minus 1, right? And n2 minus 1 sy square divided by sigma 2 square, it will follow chi square n2 minus 1, right? Yes or no? Basically, we have done for single sample n minus 1 times n minus 1 times sample, I mean s square divided by sigma square, it's follow chi square with n minus 1. The same thing we have done. This is for first sample, this is for the second sample, right? Okay. Now, see, there is one concept. Let me give you some idea that what is that concept. Suppose there is two random variable. One random variable is following. It follows chi square with n1 degree of freedom. Okay. Y is following chi square with n2 degree of freedom. Okay. So you can do a research on it. Okay. Then ratio of these two divide by n1. I mean divide by with respective degree of freedom. Same y divide by its respective degree of freedom. It will follow f distribution with degree of freedom n1 comma n2. Okay. So just keep in mind. So first is chi square with n1. So ratio of x divide by its respective degree of freedom. Then y divide by its degree of freedom. It will follow f distribution n1 comma n2. Okay. Now if you see why I'm going like this, I will tell you, because if you will be having two samples, then how will you proceed for to check the variability? Okay. Now, what is this? This is one chi-square distribution, right? And this is another kind of chi-square distribution. Yes or no? This one. Yes or no? Are you getting?
Yes, sir.
Okay. So if you see x divided by its degree of freedom, right? So what is this? Now I have this is your total x, right? And what is the degree of freedom here? N minus 1, right? If I will divide these things, divide by n minus 1, then I will take the ratio of these things, divide by n2 minus 1, it will follow f distribution, right? Basically, it will follow n minus 1 sx squared divided by sigma 1 squared divided by n1 minus 1. So this is something nothing but this form. Okay. Total divided by n2 minus 1 sy squared divided by sigma 2 square divided by n2 minus 1. Okay. It will follow f. Instead of now n1 n2, I will have n1 minus 1 n2 minus 1. Okay. Now n1 minus 1 will get cancelled out, n2 minus 1 will get cancelled out. Okay, so from here I got sx squared divided by sigma 1 square and whole divided by sy square divided by sigma 2 square. It will follow f n1 minus 1 comma n2 minus 1. Okay, so this is something called f distribution. Okay, so this is for two sample test. If you have two sample, then to check the variability in both sample, I will be using the F test. In the case of single sample, I use the chi-square test, right? So here in this case, how will decide your null hypothesis? It will be something, let's say sigma 1 equal to sigma 2. Alternative, it's let's say sigma 1 equal to sigma is not equal to, let's say, for sigma 2, for example. Okay. I mean, see, I mean, you are saying variability, I mean, population standard deviation of the first sample is same as the population standard deviation of the second sample, right? Okay, this is something I can define. Now, under H naught, means when this sigma 1 square is equal to sigma 2, then if you see, this is something, if under H naught, if you will find the F test, then this will be same, right? This will get cancelled out because this is same. So you will find sx square divided by sy square. It's following f distribution with n1 comma n1 minus 1 n2 minus 1. These two are parameters. Don't worry about this. Values for this will be given to you. Okay. So this is something to check the variability for two tests. Okay. Okay. Is this clear? Some rough idea is okay.
Yes, sir.
Okay. Now let's come to okay, come for the test for the mean itself. Okay, to test two, let's, so first we will see two sample Z test. Okay, okay, what is the key thing in case of Z test? Tell me, what is the key thing in case of Z test?
In J test, we test for the mean.
Test for the mean, that's okay. There is one thing, variance is known to us, right?
Yeah, yes.
Correct. Now, so suppose, okay, I will proceed. Let me go with the basic thing. I'm saying x1, x2, xn, and 1. I have IID normal with mean mu1 comma sigma 1 square. Okay, and y1, y2. I have another sample. It's a IID normal mu2 comma sigma 2 square. Okay, and these two are independent sample from each other. Okay, now variance is known to us. I mean, this is given to me. This is given to me. Okay, now. So Z test we are using for mean. Okay. So for single sample, we say we defined our, I mean, our claim was like mu is something specific value, right? Mu is something mu naught. Okay. But what about two sample? How will you decide your? Okay, just think a little bit. Tell me how will you decide for to test the mean for the two sample? I mean, how will you decide your claim? I mean, suppose you are two independent sample. Let's say average marks of school one, marks of the students of school one, and average marks of the students of school two. Those samples are normally distributed with something. How will you decide your claim?
Compare the mean, whether less than, equal, greater than, and
Okay, greater than or less than, right? That will
yes.
be your alternative, right? What will be your null? Null will be, I will assume basically mean of both sample is same, right? Can I say or not? Okay. And alternative will be, let's say it's not the same, or it's a greater than mu1 is greater than mu2 or something like that. Anything can be there. Okay. Okay. Anything. So I'm just going with this two tail test. Okay. Now, how will you decide? Okay. Tell me if we had one tail test. Okay. In case of one tail test, what was our test when mu is not equal to mu naught? I will reject H naught when my x bar minus mu is greater than some C, right? But here I have two samples. Let's define T as, let's say, then y bar minus x bar. Can I say or not? See, I will check the difference of both sample mean, right? Okay. So my test
Right.
will be, I will reject my H naught if when modulus of T is greater than some C. I mean, here if you see x bar is greater than some mu plus C, I mean, here it's a modulus of x bar minus mu is greater than some c, right? In case of single sample, right? I have two sample. I have defined one quantity. Let's say t is nothing but difference of y bar minus x bar, or you can say x bar minus y bar. At the end, we are taking modulus. That will not affect. So basically, let's go with this case y bar minus x bar. So I will reject my h naught if mod of t is greater than some c. Yes or no? Right? Are you getting my idea? Is this clear or not? I mean, tell me.
It's okay, sir.
Okay,
Got
fine.
it.
Okay, so what's the next step? We are proceeding with the alpha, right? Alpha is probability of rejecting h naught when h naught is true, right? That is something. So if you see, what is the probability of rejecting h naught? Modulus of t is greater than some c, right? Given that h naught. But if you see what is your h naught? H naught is mu1 equal to mu2, right? Yes or no? Okay. If you see what is the distribution of t here, tell me. What will the expected value of t?
Mu2 minus mu1.
Mu2 minus mu1 and sigma 1 square divided by n1 plus sigma 2 square divided by n2, right?
Mm.
But under h naught, what I'm saying, mu1 is equal to mu2. That means it will be 0. Right? Are you getting when? What is your h naught is? H naught is there. I have defined mu1 is equal to mu2, right? Yes or no? So under this will be 0. This part will be 0. Because I'm saying mu1 is equal to mu2, right? Then mu2 minus mu2 is 0, right? Yes or no? Are you getting?
Yeah, right.
Right. Okay. So basically, what I can say, t is distributed normally 0, comma some sigma t square, right? Sigma t is nothing but it's a quantity for sigma 1 square divided by n1 plus sigma 2 square divided by n2. It means I'm just representing this quantity by sigma t square, right? This is something I can say under h naught, because h naught, see, for two sample h naught always will be mu1 equal to mu2. Then under h naught my t will be distributed as normally 0, comma sigma t square. Yes or no? Right? So what is the next step? We have to convert in standard normal form, right? Yes or no? Okay. So how we are converting in standard normal form? Basically, we have to subtract the expected value. Okay.
Right.
In this one, it's clear, or should I do in another way? Okay, let me do it in another way. Okay? Basically, this is a shortcut one. Okay, but let me do another way. Okay, how we define t as y bar minus x bar? This is nothing but normal mu2 minus mu1, comma sigma 1 square divided by n1 plus sigma 2 square divided by n2, right? This is something we have done, right? What about t y bar minus x bar? If I can write normal mu2 minus mu1, I can define as a sigma t square, right? For simplicity, I mean, I will write sigma t square. That way, it's a sigma 1 square divided by n1 plus sigma 2 square divided by n2, right? Okay. Yes or no? Clear? This part is clear?
Correct. Okay.
So what is alpha? Alpha we took modulus of t is greater than c under h naught, right? This is nothing but probability of modulus of t greater than some c. H naught is what? Mu1 is equal to mu2, right? So add, see, what is the next step? We have to convert in standard normal form, right? If you see, what is this? Okay, to convert t in standard normal form, what we have to do? We have to subtract the mean. What is the mean? Mu2 minus mu1. Yes or no? divide by standard deviation. So standard deviation will be sigma t, right? Sigma t square is the variance, so sigma t will be standard deviation, right? Greater than c minus, same procedure, mu2 minus mu1 divided by sigma t, given that mu1 equal to mu2. So far so good. Any doubt?
No, sir. I mean, I'm
We are
okay that we are trying to go to the standard normal.
okay. We are trying to go to the standard. Okay, now under h0 mu1 is equal to mu2, then what it if you will put mu1 equal to mu2, that means it will be t minus 0 divided by sigma t, right? Greater than c minus, this part will be 0. See, if you will put mu1 at the place of mu1, you will get 0, right? C minus 0 divided by sigma t, yes or no? So alpha will be probability that this is nothing but modulus of g greater than c by sigma t. See, this will be your standard normal variable, right? So far so good. Now, if you see, in case of standard normal, due to, see, this is bell-shaped curve, right? That means symmetricity, this is z equal to 0, right? Suppose this is c by sigma t and this is minus c by sigma t, okay? Then due to symmetricity, this probability will be same. Okay, I will tell you what is the meaning of this case. Basically, meaning of all this means z is greater than c by sigma t, or z is less than minus sigma minus c by sigma t, right? Yes or no? If you expand the modulus sign, right? So it will be probability of g greater than c by sigma t plus probability g less than minus c by sigma t. Okay. So due to symmetricity of this bell-shaped curve, so probability z less than equal to minus c by sigma t will be same as probability z greater than c by sigma t, right?
Yes, sir.
Okay. So I can replace so I can simply do probability of I can replace these things with probability of g less than minus c by sigma t plus probability z less than minus c by sigma t, and it will be something alpha equal to 2 times of probability z less than minus c by sigma t. Okay, so it will be 2 times of fz minus c by sigma t. Okay, so basically I can find the value from here itself. So it will be alpha by 2, okay, equal to fz of minus c by sigma t. So from here it will be minus c by sigma t equal to fz inverse of alpha by 2. Okay, so from here I will get the value of c as minus sigma t fz inverse of alpha by 2, and from here we will get the value of c. I mean, this value will be provided. So from here we will get the value of c, and from the data we will find the modulus of t, which is nothing but modulus of y bar minus x bar. We will compare. If this is greater than c, I will reject h naught, otherwise accept it. Okay, so some rough idea is clear. Then we can move to the question. It's clear to everyone?
Yes, sir.
Okay, so let's do this question. Hopefully it will give you some rough idea. So a sociologist focusing on a popular culture and media believes that the average number of hours per week spent on social media is different for men and women. Okay, no, we are talking about average number of men and average number of women. So saying different, that means my HA is not equal to, right? It's not mention any whether it's a greater or less, right? It's saying simply different, right? If you mention like average number, I mean a number of hours per week is spent on social media for men is greater than women. Accordingly, we will decide our alternative, right? Null is always you can define as you can assume both is the same, right? For men and for women. Okay. Uh, so this hypothesis is clear. How you can define, right? The researcher knows that the standard deviation of the amount of time spent on social media are 8 hours per week and 10 hours per week. So this is what this is given to us. This is what sigma 1 for men, and this is for sigma 2. Yes or no? This is given to us without sample, right? This is one information.
Sir, by looking at the data, how, I mean, why you are coming to this conclusion that your alternate hypothesis is not the both the mu are not equal, and
Okay. What is the statement? This average number of hours per week spent on social media is different for men and women, right? We don't know whether it's greater or less. It's different. I mean, this is not equal to.
not
If
equal
we
to.
suppose statement is average number of hours per week spent on social media is more than for men than women, right? More for men than women, then it I will say mu m is greater than mu w, right?
Hmm.
Okay, not equal to means you don't know whether it's exactly greater or less. It
That
simply means it's
that
not. It's
that
different.
that part is fine, not equal to. But why that not equal to has to go to alternate hypothesis? Not why not in the null hypothesis?
Okay, null hypothesis is what? This is null hypothesis we are defining. Okay, I think you should go just brush up the things. Basically, null hypothesis is something is a statement or is a hypothesis which we are testing for possible rejection. I mean, we are making like it's a this claim is something like this. Alternative is opposite of that case. Okay, so alternative is okay. Suppose I'm saying let's do for suppose I'm saying for let's say for single case. Suppose I'm saying average number of hours per week spent for some people is let's say 10 hours. Okay, for example. I'm saying, and then I suspect this is different from 10 hours, or this suppose this is more than 10 hours. Then I will simply say I will test alternative, right? I will go for the alternative hypothesis. Okay. So null is something I will go in respect of the population parameter. Okay, I will take the some equal to sign, equality sign. This is my claim. I will check in respect of the alternative. See, if you
So,
see the test we are defining for the rejection of that hypothesis.
so is it like when the specific value we always associate in the null hypothesis and open range we go to the alternate hypothesis? Let's say,
Correct, correct. Alternative, we will you will check the see whatever your claim is there, right? You will check whether it's more than that, less than that, or not equal to that. Are you getting? So null hypothesis it's equalities basically.
okay, null is for specific, that whether it is
Correct,
equal,
correct.
same, and alternate is for open. It can be
Yeah.
less than equal or both side.
Correct, correct. Basically, this null hypothesis is the statement. Null hypothesis defined. It's kind of a statement which we are forming the statement such that we will test for the possible rejection. Okay, means you are claiming something, you suspecting, then you have made one alternative and you are testing for that alternative. See, I'm saying I will reject h naught if some case let's say x bar is greater than c. That means what? I mean, I'm trying to go with the favor of my alternative hypothesis, right? See, rejecting
Yeah,
h naught
okay,
means what? You are going to accept alternative,
right.
correct? So that is something is there. Clear?
Okay.
Okay, yeah. So if you see the okay, so examining two independent random samples of 100 individuals each means N1 is also 100 here, N2 is also 100 here, right? Just write the things whatever given in the question. So if the average number of hours per week is spent on social media for sample of men is 3 hours, okay, then the for the sample women, okay. So if you see what is this 3 hours is given to you, what do you mean by this 3 hours? Just read and tell
It
me.
is 3 hours greater than for some women of women. So yeah, so it is 3 hour more. I mean, from the woman.
3 hours more from the women. That means what? If xi, let's say xi represents the for men, okay, and y represents the for women. So that 3 hours means basically this modulus of x bar minus y bar is equal to 3, right? For
Right.
men, okay. So if you see, I have information about, see, initially we took t is equal to y bar minus x bar. So at the end we are taking modulus of t. You can take x bar minus y bar, doesn't matter. So this is 3. This is given to us, right? So if you see, okay, how will you decide your test? My test will be modulus of t is greater than c, right? So at the end, I have to check modulus of x bar minus y bar is greater than c or not, right? So value for this is given to me from the sample, which is this is 3, right? Yes or no? This C I will compute from the by the given information, and I will check whether this is true or not. Okay. Approach you are getting. Step 1 is hypothesis, right? Then step 2 you can simply say what are the information given to you, and accordingly you can proceed. I mean by defining the test and all. Okay. So your test will be modulus of t is greater than c. So far, so good. So for t, what will the distribution? X bar minus y bar, it will be mu1 minus mu2, 64 divided by 100, which is nothing but basically it's sigma 1 square divided by n1 plus sigma 2 divided by sigma 2 square divided by n2. Yes or no? This is the case. Okay. So now if you see, I will proceed with alpha. Alpha is probability of rejecting H naught. So I will reject H naught. So alpha is what? Let me write down probability of rejecting H naught when H naught is true. I will reject H naught when modulus of T is greater than C. Now we know modulus of T is what? Here, if you see under H naught, it will be follow normal. Under H naught, it will be what? It will be 0, right? Mean will be 0 because we are considering mu1 is equal to mu2. It will be 0, comma 164 divided by 100, right? So if you see here, it will be minus 0, and divide by square root of 164 divided by 100 greater than c minus 0 divided by square root of 164 divided by 100. Basically, we are following the same procedure which we have done in case of single sample. Now, this is nothing but your z. So modulus of z is greater than c divided by this whole quantity. Now, a few minutes before we have discussed this case, right? At the end, it will be 2 times of probability that z less than minus c by sigma t. So if you see, we have taken the minus value. Okay. So from here onwards, it will be fg inverse of alpha by 2. Fg inverse alpha is 5%. So it will be fg inverse 0.005. This value is given to me. Okay. I computed, I have put this value from the question, and we got C is the 3.29. Now, we decided I will reject, we decided our test, I will reject H0 if modulus of T is greater than C. But here in this case, modulus of T is less than C, right? That means what? I will accept H0. Okay. That means you will say average number of hours spent by men and average number of hours spent by women is, you may accept, right? It's a same, not different. Is this clear? See, some approach you are getting, right? I mean, the steps are very similar, right? Hypothesis, then test, then just identify whether it's a Z test, T test, or something else. Then proceed with alpha and convert in standard normal variate. If its variance is known, I can convert in Z test. If its variance is unknown, I will convert in T test. If it's test for variance, then I will convert in chi-square test, right? If it's for two test, I will convert in modulus of T. And modulus of T is nothing but it's again standard normal variable. I mean, I have to convert in standard normal form. Is this clear?
Yeah, yes, sir.
Okay, clear somewhat, right? I think people are left the session. Okay, no problem. Okay, so there was one test left, app test. Okay, so do you want to discuss this right now or next session?
I think next session we can continue, sir. I have one doubt on the
Yes.
importance wise, like
Hmm.
question. I mean, week 9, 10, and 11, 12. What is the weightage like from 9 to 12 and 4? I mean, 5 to 8 and 1 to 4.
Okay, okay. So exact weight I will share on the discourse or in the next session most probably. Okay. Basically,
Mhm.
I to calculate the exact weightage, but one thing is very clear. Major portion will be from 9 to 12. Okay.
9 to 12.
Yes.
So,
Major like method of movements, that maximum likelihood, Bayesian estimation, and all. Okay.
mhm.
Okay, you may get some questions from week 12, but not that much lengthy you will get. Just need to clear with the concepts. Okay.
Okay, so mostly week 9, 10, 11, 12,
Yes,
and
and 1 to 8.
1 to 8. In that portion also some more importance, like less importance, like week 5, 6, 7 more important.
Not sure. I will share
Mhm.
the exact week wise weightage. Right? I
Okay.
mean I will share 1 to 4, 5 to 8, and then 9 to 12. Okay. Accordingly you can. But there will be less questions from 1 to 8. I mean there will be one or two questions from 1 to 4. Okay.
Mhm.
So and one and two question from, let's say, one and two question means including subparts I'm talking about. Okay, from
Mhm.
5 to 8, and rest of the question from 9 to 12. You will get some less question. I mean, not that much lengthy question from week 12. There will be some conceptual questions from week 12, but yeah, from week 10 you may get some. I mean, for single sample you will get some questions, but abject value and all will be given to you.
Mhm.
Okay. I mean, we will release the mock test. Okay, by this Friday we are going to release the mock. Okay, mock for enter. You can expect the accordingly weightage and the things as per the mock for enter. Okay.
Okay, sir, understood. So mostly around 16, 17, 18 question is there on average. So in that,
Maximum, yeah, yeah, around 16. In out of 16, 5 to 6 question will be like 3 marks questions, right? So those
mm,
3 marks questions will be straightforward. Straightforward means you have to just do some simple calculation, you will get the answer. But
mm,
rest of the question, I mean, you have to put your effort.
mm. Sir, this, I mean, maybe it is not the appropriate form. In the quiz too,
Mhm.
what I have experienced is that I was able to approach to the problem, but the final calculation value, what it was given,
Mhm.
and, what I was getting, it was not matching with the expected value options given in the questions. Then
So
further, we have to manipulate and get to that form. It was something like that.
okay, I think it was in the very last question, if I'm not talking. That CLT,
Some,
CLT. Yeah, yeah, there was in that question. But okay, so that was something like if you are going with some simple calculation, right? Let's say 2/4 is given to you, right? So you can just
mm,
cancel and you will get 1/2. Okay. So that was in the
mm,
one question I can remember that question, but you will not get any question related to that in Entom. Okay. Even though in Entom, we are providing some, suppose there is some difficult integration or some difficult calculation, let's say 0.8 raised for 9. Okay.
mm.
So we have provided those values also.
I mean, I understand if we
Hmm.
want to learn something that we need to go through this, but
Yeah, yeah.
different people will have different challenges.
Correct,
For
correct, correct.
say, for me, main thing is the time to manage the time spent, need to go through the practices, and it is extremely difficult. But yes, if we want to learn, we have to go through that.
Yeah, yeah. Just go through once. If you still your doubt, so you can tag to us in on Discord, something like that. I mean, in suppose you are solving any problem, right? Just take, or you got stuck somewhere. Just take the picture, or you can tag to us. Right? Yeah, this is something I have done, and I'm not getting after this. Then we can discuss on it, right? Or TA session is going on. You can join that. You can ask your doubts there also, right? There are lots of things, but yeah.
Yeah, sure.
Okay. Oh, okay. Then just go through the app test. App test is just okay. So in the, let me give you some quick ideas. So like mean, we were checking mu1 is equal to mu2, right? App test will be, okay. Tell me, it will be sigma 1 square equal to sigma 2 square, right? App test means to check the variability. Okay. So to test for the variance, if you have single sample, I will prefer the chi-square, and if I have two sample, I will go with the app test. Okay. It will be, I mean, initially I took that ratio of first sample variance. I mean, S1 square divided by S2 square, and we have to this information will be given to us from the sample, and I can. I mean, just go through that, solve with the speed of week 12, right? There is questions related to that, and solution as well. Just do that one. If you still you people have doubt, we will discuss on that. Okay. Okay then. Thanks. We'll meet in the next.
Thank you, sir.